solving trigonometric equations. That's what we need to be able to do. It says solve each trigonometric equation in the specified domain and give a general solution. So we're going to solve it between 0 and 2 pi, and then we're going to do that general solution as well. This equation, when we go to solve it, we're only looking at this part of it, right? That other part is just the restriction on the domain. So this is what we need to solve. How are we going to do that? Combine like terms, right. So we'll move all the signs to one side and the numbers to the other. So if I subtract 3 sine from both sides, I have 5 sine over here. Subtract the 3 sine, I have 2 sine theta. And then I had 1 on the right, but I'm going to subtract 2. So I'll have -1. So combine like terms and then isolate the trig function. So I want to get the sine theta by itself. I need to divide both sides by 2, and I'll have sine theta, oops, try that again, sine theta equals -1/2. Now it's just like what we were looking at before. We need to go to the special triangle to figure out the reference angle for this one. The special triangle that we're going to use is the one that has a 1 and a 2 in it. So this one. And we just need to decide, is the reference angle pi over 3 or is it pi over 6? When we look at that special triangle, we're looking for which of those angles has a sine of 1 over 2. So sine is opposite over hypotenuse. If we choose pi over 3, the opposite is root 3 over the hypotenuse 2. Root 3 over 2 is not what we're looking for. So look at the pi over 6. Opposite is 1, hypotenuse is 2. So pi over 6 has a sine of 1 over 2, which means pi over 6 is the reference angle. And then we need to figure out which quadrants our actual answer is in. We're looking for a negative sign. So which quadrants have a negative sign value? So that's right, 3 and 4. And so then the angle that we're looking for in there these are sixths. I didn't draw them very accurately, but we know that all the way around to pi that would be 6 sixths. So this one must be 7 pi over 6. And what's the other one? 11 pi over 6. Those are the answers in the specified domain. So between 0 and 2 pi, we have 7 pi over 6 and 11 pi over 6. It says then give a general solution. So the general solution is just going to look like 7 pi over 6 and 11 pi over 6 plus 2 pi n, where n is an integer. Because we're going to get those two answers, but then if we go from either of those answers another full rotation, another 2 pi, we'll get another answer. And then if we go another 2 pi after that, we'll get another answer, and we can keep doing that. Or if we subtract 2 pi's. That's why it says n is an integer, because you can add or subtract 2 pi and you'll get another solution. So the same as the previous question, get the cosines together. So I'll subtract cosine from each side to leave me with 2 cosine theta on this side. And then add 1 to both sides. Oh. Did we do this question already? Basically, we had a 2 cosine theta equals 2. That's okay. Then divide by 2 and we get cos theta equals 1. Because you can't find a 1/1 on a special triangle, except for tangent, we need to look at the quadrantal angles for this. And we're right here. This is where cosine is equal to 1. Remember, the x coordinate is the cosine value. So 0 and 2 pi, but if you look at the domain it gives you, it's negative 2 pi to 2 pi. So your answers are actually going to be negative 2 pi, 0, and 2 pi. But if you wanted a general solution, it would just be 2 pi n.
Wait, so do you not have to write like something plus 2 pi n as like the starting point, or?
Well, not if the something is 0,
Oh, okay.
right? This one is asking you for what values of theta is cosecant theta undefined. Just have to think a little bit more about that one. Cosecant is the reciprocal of sine. So if cosecant is undefined, what's the reciprocal of undefined? Undefined is something over 0.
Also 0 over something.
0 over something is the reciprocal of that. So we're actually looking for where sine theta is equal to 0 over something, which is equal to 0. We're looking for where sine theta is equal to 0 because we're looking for where the cosecant is undefined. And the reciprocal of undefined is 0. So if we look at these quadrantal angles again, sine is the y value. Here's where sine is equal to 0. It's at 0 and pi and 2 pi, right? And 3 pi and 4 pi, every pi. So cosecant is going to be undefined. Zero, pi, and 2 pi. If we're working on that domain, it doesn't tell us here, but if we're working on that domain, oops. Between 0 and 2 pi, or let's do this. Between 0 and 2 pi like that, then it's just pi and 2 pi, if we don't include 0 in the domain, which often you'll see. Then the values are pi and 2 pi. The general solution would be what? Pi n. Every pi. Cosecant will be undefined. This is the last one that we're going to solve today, and we're just going to solve it on that domain from 0 to 2 pi. Let's start by figuring out what angle has a sine of 1 over root 2. And the answer is pi over 4. But instead of saying theta is equal to pi over 4, it's 3 theta that we're solving for. So we're going to say that 3 theta is equal to pi over 4. That's actually the reference angle, but because it's positive, it's one of the solutions. We want to be in the first and second quadrant for sine to be positive. So it's pi over 4, and what's the other one? Three pi over 4. But that's what 3 theta is equal to. How can we algebraically figure out what theta is equal to? Divide by 3, right. So we want to divide 3 theta by 3 to get theta. We'll divide pi over 4 by 3, and what do we get? pi over 12, and divide 3 pi over 4 by 3, and we get pi over 4. And that's good, except that it's not all of the answers. Because we found all of the angles for 3 theta that are between 0 and 2 pi, but not for theta. So if we were going to find another answer for 3 theta, we'd have pi over 4, 3 pi over 4. What would the next one be? So from pi over 4, if you go all the way around again, 9 pi over 4 would be another one. But what is 9 pi over 4 if we divide it by 3? Three pi over 4. That one's still good, 3 pi over 4, because it's still between 0 and 2 pi. What would be the next one after 9 pi over 4? 11 pi over 4? Because if we went all the way around and to there again, there's 8, 9, 10, 11. Oops, 11 pi over 4. I'm running out of space here, I'll just put it over here. 11 pi over 4. Divide that by 3 and you get 11 pi over 12. Is that still small enough? That's still just between 0 and pi, right? So keep going and finding more solutions until we get to a solution that's too big. If we kept going around again to this one, so we'll include 17 pi over 4 and 19 pi over 4, which for solutions here would be 17 pi over 12, 19 pi over 12. That's a lot of solutions. But those are all the solutions between 0 and 2 pi. So this is basically a continuation of what we were doing with solving equations, but this equation is more complex. Remember though, again, we're looking, when we're solving, just at this part. The other part is the restriction. It says we want answers between 0 degrees and 360 degrees only. Because, remember, there are actually, if we don't put a restriction like that, an infinite number of solutions. But this is saying just give answers that are between 0 degrees and 360 degrees, which is also kind of different because we haven't been working that much in degrees, but that should be fine. So if it gives you a restriction like that, then we want our answers to be in degrees. But this cosine squared theta minus cosine theta minus 2 equals 0 is kind of a complex equation. And so one way that we deal with complex equations is by making them simpler. And we make them simpler by doing a substitution. If you remember, in grade 10 was when you first learned to solve by substitution, where you had 2 equations and you substitute one into the other so that you can solve for just one variable. We're going to do the same thing here, even though we only have one solution. This is a common strategy that people use to solve equations when they're complex, and it's something that you should think of when you get to an equation that's complicated. So what I'm going to do is decide on what I want to substitute. And so I'm going to look at that equation and say, what's common that I could replace with something else? And the thing that I see showing up there more than once is the cosine theta. The other thing I should point out that this cos squared theta is actually just cosine theta squared. But that's the way that we write it, as cos squared theta. But these two mean the same thing. So what I'm going to do is make up a substitution. So I'm going to say I will let x equal cosine theta. And if I do that, then I can replace every cosine theta with an x and make the equation easier to solve. So now I'm going to take this equation that we were originally given and change the cosine thetas into x's. So I will have x squared minus x minus 2 equals 0. And that's something that you should know how to solve. Now we just have a basic quadratic equation, and I can solve that by factoring. So I'll go x, 2, 1. How's that look? X squared minus, yeah. Now it's factored, and now my solutions are x equals 2 and x equals -1. But those aren't the answers to the problem. Those are the answers to this kind of made up problem, right? I put the x in there kind of arbitrarily as something to help me solve, but the question's not asking what's x equal to. The question's asking what is theta equal to. So now I have to substitute that back into my made up equation, my x equals cosine theta, and we'll get 2 equals cosine theta and -1 equals cosine theta. And now those I can solve. Cosine theta equals 2 and cosine theta equals -1. We've probably seen before cosine theta equals -1. And we know if we have a -1, it's going to be one of those quadrantal angles. So 1, 0, 0, 1, -1, 0, 0, -1. Which of those points are we looking at for cosine equal to -1? That's right here, right? Yeah. Cosine is the x value. So it's at, we're talking in terms of degrees. How many degrees is that? 180. So for this one, I can say theta equals 180 degrees. How about that cosine theta equals 2? It doesn't exist. If you think about these special triangles, one of them does have a 2 in it, right? But the 2 is the hypotenuse. Cosine is adjacent over hypotenuse. And if you think about it, something divided by the hypotenuse is never going to be bigger than, do you know what value? 1. Because the hypotenuse has to be the biggest side in a triangle. So if the adjacent always has to be smaller than the hypotenuse. And so cosine can never be bigger than 1. Because if it is 1 or greater, then the adjacent would have to be bigger than the hypotenuse. And that goes against the whole idea of what a hypotenuse is, right? It has to be the biggest side in the triangle. So there's no solution for this part of it. Which means, actually, this is the only answer for that question. Here's the next one that I want to do with you. 2 sine theta tan theta plus tan theta equals 0. And theta is going to be between 0 and 2 pi. We could do a substitution for this one as well, but we'd have to do 2 substitutions probably. So I don't think it's the best way to do it. Anybody have an idea of how you can solve this? Think about what we did in the last one with factoring. So yeah, let's factor out a tangent. If I take the tangent out, then here in this first term I'm left with 2 sine theta. And in the second term I'm just left with 1. Now I have these 2 equations. Tan theta equals 0 and 2 sine theta plus 1 equals 0. And those are both equations that we're able to solve. To solve tan theta equals 0, think of the quadrantal angles again. And do you remember how tangent works on here? It's sine over cosine. So if we're looking for where tangent is equal to 0, we're basically looking for where sine is equal to 0. And sine is equal to 0 at 0 and at pi. And at 2 pi, actually we don't want to include the 0 if you look at the restriction on the domain. So from this one we'll get theta is equal to pi and 2 pi. Isolate sine theta in this one and we get sine theta equals -1/2. Subtract 1, then divide by 2. So that's going to be this special triangle, 1, 2, root 3 with the pi over 3 and pi over 6. So we need to say which of those two angles has a sine of 1/2. Is it pi over 3 or is it pi over 6? Pi over 6, so the reference angle here is pi over 6. Remember, sine is opposite over hypotenuse, and that's why it's pi over 6, because opposite the pi over 6 is the 1, and the hypotenuse is 2. So that gives you a sine of 1/2. Reference angle is pi over 6. We'll look at which quadrants we should be in. 3 and 4, because it's -1/2. So we're going to have a pi over 6 reference angle here and here, which means we have 7 pi over 6 and 11 pi over 6. So answers are here and here. So to solve this one, I'm going to actually probably do a substitution again, even though I only see sine in one spot. I'm going to change it to an x to make it easier to deal with. So I'm going to say let x equal sine theta, because I think it'll make it easier if I replace that sine theta with an x, which means I actually have to do x squared minus 1/2 equals 0. Because it was sine squared, so I make it an x squared. Do you know how to factor that? It's a difference of squares, right? Even though 1/2 isn't technically a perfect square, we're going to factor it as a difference of squares. So if you remember, a difference of squares would be like a squared minus b squared, and it would factor to a plus b, a minus b. Remember that? So I'm going to do the same thing with this. So I'll do the square root of x squared is x plus an x minus, but what goes in here in those blanks? So in that blank, we're going to put the square root of 1/2. Square root of 1/2 is equal to the square root of 1, which is 1, over the square root of 2. So I'll do 1 over root 2. Instead of putting it in like this, over here on the right, the square root of 1/2, I'm going to actually take the square root of 1, it's 1, and then take the square root of 2, and just leave it as root 2 because it's irrational. And we'll put a 1 over root 2 in both of those spots. And then I can do x equals -1 over root 2, and x equals 1 over root 2. Which means sine theta equals -1 over root 2, and sine theta equals 1 over root 2. Make that a little smaller. So a special triangle that we're going to use for this one is this with a pi over 4. Sine of pi over 4 is 1 over root 2, which makes the reference angle pi over 4. And actually, if you look, sine theta equals negative 1 over root 2 and positive 1 over root 2, which means we're in which quadrants? All of them. 1, 2, 3, 4. So theta is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. That's if we want our solutions between 0 and 2 pi, which I didn't write down that restriction. But that's what is gonna happen most often.